So we're an AWS to IoT connected home solutions. My name is Wally Oladihan. I'm a senior solutions architect focused on IoT. And today we have with us Mike Moss. He is a senior evangelist for Amazon Alexa. So what are we going to cover today? So I know there's been a lot of sessions going on, so I'm not sure if you made it to IoT sessions or not, or if you decided to send them an ML session or another kind of track. So we will do kind of a quick overview of the AWS IoT services. I want to focus on the ones that are primarily seen in smart home implementations. So a lot of my focus will be on how do people use this in the home, what services do we see from AWS, and how do you expand that to get into specific use cases. From there, we'll actually show an example of just implementing a basic smart home solution integration. And for that, we'll use Kinesis video. So we'll show how to do like a security camera using AWS IoT and Kinesis video. And then we have the pleasure of actually diving into Alexa and how you can bring voice to your applications. So with that said, let's start with an overview of AWS IoT. Just to get an idea, how many of you have used AWS IoT, either Core, Greengrass, Device Defender, Analytics? OK, have a few people. You've probably seen this chart before. I kind of go from your left to right. When we think about the left in terms of things, we're thinking about like the SDK. So our SDKs allow you to quickly connect devices to AWS IoT. But in that reInvent, we also launched Amazon FreeRTOS. So we extended FreeRTOS so you can actually connect MCUs and kind of constrain devices directly to the cloud, and then do things like control like shadow state and kind of command and control, or just send telemetry. When we move over a little bit, we get into like more of the Linux-based kind of embedded systems where you're doing Linux. And this is where Greengrass really comes into play. So Greengrass allows us to kind of push a lot of the AWS IoT logic closer to the edge. And I'll kind of talk about all those different components in a few slides. Then when it comes to smart home, you actually have to communicate with stuff that doesn't exist within the person's home. And this is where the cloud aspect comes in. We have AWS IoT Core, which is what most people are familiar with when you start with AWS. It's where you do all of the publishing and subscribing of messages back and forth between devices and the cloud. We have device management. Device management allows you to quickly onboard devices. So we'll talk about all the features inside of it, but we wanted to make it easier for you to take a device, kind of get it unboxed, get it connected, and then manage the life cycle from basically birth until it's time to be deprovisioned. Then we have Device Defender. This is a way that you can do audit checks against your cloud ecosystem. So our security policies to open our devices sharing certificates, which they should not be. So it allows you to take proactive action and make sure that when you give these devices out to your consumers, they're configured correctly, and we continually check against those audits. And then analytics. So when it comes to the analytics use case, it's trying to figure out in a smart home, like, how do you better serve your customers? So how can you look at saying, how can I do replenishment ahead of time? That I know that my customer has been using their cleaning products for a certain amount of time, it's going to expire soon. How about I send them a push notification so that you can maintain the life cycle of your product for a longer period and you create a better customer experience? So using all of these pieces together really allow customers to build smart home applications on AWS IoT. So now that we know kind of the breadth of the AWS services, I'm going to focus on the ones that come up most frequently in smart home. And the first one is AWS IoT Core. This is really the front door to AWS from an IoT perspective. So it allows you to securely connect your devices. The other thing I want to point out is that we have the ability to, once you communicate to AWS, kind of route messages to different places. So you go from AWS IoT, and you want to go to Lambda, or you want to upload that to DynamoDB, or you want it to go into S3. Via AWS IoT Core, you can then reach these internal services and not require your devices to have all these different sets of credentials just to communicate with them. So if we look inside of AWS IoT Core, there's basically these sub-services. And if you think about AWS and kind of the two pizza teams, think about these as all individual services that are inside of AWS IoT Core. On the left, we have our identity service. So what we do here is we allow devices to use X509 certificates for identity, and then you can use those certificates to communicate directly to AWS IoT. In the demo later, I'll also show that you're able to use those certificates to actually get short-term IAM credentials to go communicate with another service. So if you really had to have a device go and communicate to like a Kinesis video stream, you can actually use the identity service to give it temporary credentials. And now you don't have to take these IAM credentials and kind of hard code them in your manufacturing. You can still keep this fine-grained certificate information on each device. We have the device gateway and a message broker. This is basically an MQTT protocol. We allow you to publish on a topic and then subscribe to a set of topics. We manage all of the routing, so devices can subscribe on wildcard topics. And from a publishing perspective, we manage the scaling of all the publishing for you. So if you have one device publishing or a million device publishing, we basically scale the device gateway and the broker to handle that load and input. We have the rules engine, so every single time a message fires, the rules engine can be used to route that message to an internal service. You can basically say, whenever I publish on the hello world topic, that should go into S3, or whenever I publish a hello, anything that starts with hello, that should go into a Lambda function that then goes and sends a push notification. Then we have the device shadow and the registry. Think about the shadow as kind of storing metadata for your device. So it's kind of the mutable information that changes inside of the home. Is this light on or off? Can I change the hue of the light so it's red with the tint, or can I change it to green? When you're kind of doing this command and control or just getting reported state, you end up using the shadow for that. Then you use the registry for more of your immutable data. So in a smart home scenario, when a customer first unboxes, they might have a serial number for their device. That's what goes in a registry. It's a way that you can go back later and say, this customer has just enabled this device, here's a serial number, here's the birth when they first created it. Now I just need to find this kind of static data somewhere, and the registry is a great fit for that. Since core is going to be the primary entry point for AWS IoT, I want to dive into a little bit about MQTT topics and security a little bit deeper. So as you think about smart homes, start thinking about, well, how do topics work? How do I structure them? How do I build applications for my use case? So you think about MQTT topics first off as being ephemeral. They technically don't exist anywhere. So people always say, well, where can I find all the topics? It's like, topics actually don't exist. It's kind of like a tree in the forest and no one's around. If no one is publishing or subscribing to the topic, it's not stored. It's kind of created in real time, just so we can figure out who's listening and where do we send the messages to. I mentioned before it's a pub-sub model. So we've basically decoupled the senders from the receivers. What this enables you to do in the cases of smart home is you can basically have your mobile app say, I want to receive notifications for everything in my home. And just in case my mobile app is like in my pocket, or let's say my device is no longer connected, I don't have this like persistent channel that when one side's broken, the other side can't listen. Because it's bidirectional, we've decoupled it. Once it gets up to the cloud, you can then kind of route things down. And using things like the shadow, you can even store those last states so they can be routed down to the device later on. And then we have a concept of wildcarding. I mean, how you can think about wildcarding, especially in smart homes, is that it allows you to create an area of interest when you're implementing a smart home solution. So in the first case, I can do a single level wildcard, where I can say, I want to listen to any temperature change that happens on the ground floor. So I might have, a long, high-rise condo building, and I want to understand what the temperature is within the first floor so I can make changes. We can get even more advanced because you can spot multi-level wildcarding. So you can say, well, I just don't care about temperature. Maybe I care about temperature, humidity, maybe I care if the windows are open. So anything that happens on the first floor, I want to listen to. You don't have to make any device side changes for this. Just by subscribing and changing the plus to a pound symbol, you're able to get this additional data. So just to show an example, I have a publish for all my devices. I'm going to publish your temperature on a home/AC. The client ID is just a unique identifier for each device. And on the right, I'm going to subscribe, and that's going to be a home/AC, a single level wildcard with the plus temperature. So now all my devices come in. Whether I add new sensors to the home, because I've created a topic structure that says anyone within this home publishes on this set topic, as these come online, they all get routed to that one subscription. So again, think about that kind of mobile use case, right? If I start adding devices within my home and I want to be able to control them, I don't want to have to go through this whole process where I've got more and more topics to listen to. I want to understand what's happening in my kitchen, and that's a set of topics I listen to, versus what's happening in my bedroom, which is another set of topics that I'm listening to. And whenever I add them, just by adding that contextual information, I'm now able to kind of aggregate this all into one place. We expand on that by actually putting security on top of all of this type of communication that happens. So we understand in the home, we want to make sure that as you actually build smart home products that you can have like encryption end to end. You can identify what the device is. You can make sure that the full kind of TLS handshake is operating correctly. So from that perspective, with AWS IoT, we kind of bundle in this authentication authorization basically for you as a service. So there's going to be a lot of lines that come up, so I'll bring them up in kind of a group, and I'll speak to them so you don't go, there's a lot of lines going on here. Well, what happens in the first part is basically a full mutual TLS handshake. So the device will basically say, I've got a certificate, I'm going to send it to AWS IoT, I keep my private key private. It's going to say, I also want to understand if you are the server I should be communicating with. The server is actually going to sign something with their server certificate. So this is going to say to the device, you can trust me, here's my server certificate. On device, we actually still have a root CA that goes with each device that identifies that endpoint, the MQTT broker you're connecting with. It uses that certificate to now validate, this is the endpoint I'm supposed to be connected to. Once that happens, your device can continue its connection, so it can make a finished MQTT connect. And then whenever you actually make an action against AWS IoT, whether you connect, subscribe to a topic, publish, or whenever you receive a message, we will actually check the IoT policy to see if it has permissions to do that. Can this device publish to this topic? Can this device receive a message from the first floor of the home? And if it's allowed, we then allow that outbound message or that publish to come through. We also extend the same functionality for users as well, because we understand in the home it's not just devices. So we have Alice, her past name is Red Queen. I didn't hash it, maybe I should have. But a very similar process happens here as well. So like we were going to go through a full TLS handshake, but instead of using X509 certificates, we're going to use IAM credentials. Normally these IAM credentials are using Cognito, so you can identify each user to their accounts. And then through this process, the same thing happens at the end of the day. Every single time Alice makes an action, whether she's publishing, subscribing, connecting, receiving a message, we'll check that Cognito identity, saying this is Alice. We'll go and look at a policy for it and make sure that Alice can only do what she's supposed to be able to do. This allows us, again, to kind of make sure everything happens in the context of the home. So now that we've talked about AWS IoT Core, the other common use case we see inside of the smart home is AWS Greengrass. And you think about Greengrass is how can we bring some of the IoT functionality I talked about closer to the edge? How can we make it easier for you to kind of have local connectivity but have a lower latency? So you can think about Greengrass as a daemon that runs on a Linux machine. And in that daemon, you basically have a lightweight MQTT broker. So all of the pub sub model that I talked about earlier in IoT Core basically applies at the edge for Greengrass. But now, let's say something's offline and you still want to understand which set-top boxes are online, how's the Wi-Fi router. You can do all of that via Greengrass because all the communication happens over the local network. Within Greengrass, we extended it to also be able to trigger your own Lambda functions. So inside this machine, if you decide to publish a message and you want this message to invoke a Lambda function, we'll check the topic, say this needs to invoke a Lambda function, and that Lambda function might go and push a notification to a user's phone. It can even go and upload things directly into your AWS account because it can actually vend temporary permissions to go talk to other services. It allows you to kind of operate offline or still communicate some pertinent information to the cloud. We have data sync, so the whole shadow concept is replicated locally. We also replicate all of the certificate security metrics locally as well. So the same kind of certificate information you needed to communicate directly to AWS IoT, you also need to communicate with Greengrass. The things we see most commonly in smart home are actually in the kind of machine learning inference space. So you want to be able to deploy something so low latency, you can actually take an action. I want to understand when someone enters my home, is this a neighbor that I've seen before? Is it my kids? Is it my dog running back and forth and it shouldn't send me a push notification because it's just my pet running around? Instead of going back to the cloud each time to send these images back and forth, you can actually push those ML inference models locally and say, whenever something triggers, trigger this Lambda function, check and take a picture of it. Let me know if this is a cat or a dog or a person, and have you seen it before? If you haven't seen it before, yes, please send me a push notification. But if you have, it's totally fine. No need to communicate with the cloud. The last set of services we see in the smart home use cases is actually AWS IoT device management. And I mentioned device management because the most important part of smart home is making sure you can unbox something successfully. When a user can open it up, they can get it running as quickly as possible, everything's pre-provisioned for them, and the onboarding is very, very smooth. Oop. So with device management, what we've done is we've created basically a provisioning template you can use to create the attributes for your device. You can then have additional search capabilities on top of those device attributes. So you can do things like only find devices that are offline and have been on the dock for five minutes. And we've also created the ability to do over-the-air updates. So as you understand your users, you can actually deploy updates to those users. So now that we know about all the AWS services, how do we start applying that to some of the smart home use cases that you see? So when you think about the connected use cases, we kind of put connected home in 3 different verticals. We think of like home automation. So that's how do I have all these things coordinate together? You know, how is it when I wake up and I put my feet down that the coffee pot starts, you know, the car starts warming up because it's cold, and my weather report starts running? We have the home networking, which comes up often in the case of Greengrass. I want to understand how my network is performing. I don't want you to send all of it to the cloud. Just look at what's happening locally and let me know, is my network performing correctly or not? Then we also have the home security use cases. And when I dive into the demo later, this comes up often when you want to actually communicate, as I mentioned, like kind of image capture. I might be streaming video all the time, but now I want to do something locally and do image capture. Do I need to take an action or not? Do I need to call 911 because I hear a crack of the window and I know that that's someone coming into the home? So these are kind of the 3 pillars we see most often with smart home and connected home use cases. And we understand some of the challenges that customers see here is that, you know, it's hard to kind of differentiate in a crowded space. There are a plethora of protocols even in smart home. You think, okay, it's Bluetooth 4, then Bluetooth 5, and then you want to use Zigbee. So how do you kind of galvanize all these solutions together so you can have a little bit more interoperability? We're also seeing more and more the need to have kind of local intelligence at the edge. So instead of actually sending everything back to the cloud, you want to make sure the home can operate whether you're offline or online. You want to make sure even if the network's down, I can still kind of coordinate all these actions within the home. And as I talked about all of those services earlier, whether it's IoT Core, Greengrass, device management, the primary focus for AWS IoT is to kind of take away a lot of that undifferentiated lifting that you have to do. So you don't have to really manage connectivity or think about like identity and manage kind of the TLS connection. All of that's done through the AWS IoT service. The other thing we want to focus on as well is that because we allow you to take your identity and not just use it to communicate with AWS IoT, but also allow you to use it to communicate with other services, how can we make it easier for you to take that identity and build new applications quickly? You might start off building a smart camera use case, and you're streaming to Kinesis video, and then eventually, like, I want to do ML inference. I want to use something like recognition. Well, now you've already have a pathway to go from one service to another because you're already using kind of this underpinning of identity and best practices in AWS. So just a recap before kind of diving into the demo. We kind of have 3 different areas. We have the home. So this is all of your IoT edge. This is Amazon FreeRTOS and Greengrass. We have the cloud for kind of managing all the connectivity and states of the device. That's core device management, device offender analytics. And then once you have that in place, you then start to broaden the ecosystem of smart home applications, whether that's mobile, whether that's Alexa, whether that's integrating with smart TVs. This all becomes much easier once you kind of have that identity and communication from your device through AWS IoT. Just to show an example, kind of implementing this and seeing how quickly you can get up and running, I'll show kind of a smart home security use case. So it's not a full end-to-end, but we'll focus on kind of streaming video through Kinesis video. As you think about this, you can think about expanding this use case. As I mentioned, we have customers that start with Kinesis video, and then they say, OK, I want to do machine learning in the cloud. OK, now I actually want to do that closer to the edge. Oh, now I want to send push notifications in the cloud. Oh, how can I do that closer to the edge? So in the same kind of security use case, the patterns will apply for not just using Kinesis video in AWS IoT, but any other services that you're looking to leverage that are in AWS. I'm going to skip this slide. It's supposed to be hidden. So, what will our architecture look like in the demo? I'm going to have an IoT thing camera. This is going to make a call to AWS IoT. It already has a certificate provision on it. That certificate is going to allow me to communicate to another AWS service. Behind the scenes, AWS will take care of this for you. What we'll do using this credentials provider service is we'll look at the role you want us to assume for that device, go and get permissions for it, and then turn around and send it down to the device. At that point, I'm going to start streaming video to Amazon Kinesis Video. So again, kind of in a smart home use case. Also, what will happen is that I can continue to use that same channel for regular telemetry. So I might be streaming video on one channel, but now I want to send notification on another channel. And I'm still able to do that because the same certificate can be used to talk directly to AWS IoT. And you can still make use of other services. So I don't really have a mobile application, but if I wanted to listen on that channel, I could use Cognito just to listen directly on that telemetry channel as well. One thing I'll point out, and I won't show it in the console, is that with the credentials provider, you're actually able to give it fine-grained permissions as well. If you look in the kind of green area, I've got credentials dash IoT thing name. So through this kind of X509 certificate, I can say, you can go and talk to Kinesis, you can get item and describe, but you can only do it for your Kinesis video stream. Only you as a thing can only communicate with your thing in the cloud. So this gives you the ability to have really fine-grained permissions. Only you, thing one, can upload to this S3 bucket or this path in S3. So this just gives you a lot of ways to just make sure you can divvy up your data and make sure there's kind of this security end-to-end from device to the cloud. So with that, I'm going to switch screens, hopefully seamlessly, and then hop into the demo. That was seamless. OK. So I have a Kinesis video stream. There's nothing streaming because I haven't started running it yet. So to show that it is actually going to be working as planned. Kinesis Video, it has this really nice Kinesis Video client. So if you ever have used it before, you basically can just download a couple packages, run some JNI linking, and then run demo, and it'll start running for you. What I've done to extend it is I'm actually going to use AWS IoT to give me permission to go talk to my video stream. So my security camera doesn't have hard-coded credentials. The intent is that it only has this certificate where the private key is stored somewhere privately, like a TPM or like a software-based kind of secure element. And this way, I don't have to have IAM credentials. I don't need to create a random thing user. I'm just going to use a certificate. I'll just point out at the very end. What will happen when I run it is it's going to make that one-time call. It'll say successfully getting credentials, and then we'll see the video kick in. So the movie magic, the warnings I just haven't removed yet. But if you notice, the debug statements are kind of saying, you have this stream in the cloud, you have this X509 certificate. I can't communicate with it because I've got no permissions to go and talk to this application running in the cloud. But you have given me permissions to AWS IoT. So it's going to take those permissions and actually go and get an IoT session credential. No IAM, nothing else other than the certificate. And then what's going to happen is now, because it's my security camera, it's going to take that, turn around, and start streaming video to the AWS cloud. And so what you can see, this is what you see in a demo application, is just like one kind of still frame that loops over and over again. But it's now sending this up to Kinesis Video. And I've actually made sure that only my camera can stream to this Kinesis Video stream. So from a security perspective in the home, I'm making sure that no user can really tap into someone else's stream because we've passed this thing metadata all the way up. Cool. So with that, I'm going to hand it over to Mike so we can kind of expand further in smart home use cases with Alexa.
Thanks, Wally. Hi, everybody. How many people here have ever built an Alexa skill? Anybody? One? That's good. Two, three, good. I'm not going to talk too in depth about what it takes, but it's definitely an interesting journey. One of the things that I'd like to point out is everything that I'm going to show you, from the content to the demo, is really building on AWS IoT and the services that AWS services give us in the first place. So Alexa Skills Kit really is our toolkit for building Alexa skills. It's the console interface, it's the SDKs, it's the documentation, it's the whole package to allow you to craft skills that enable you to give Alexa more functionality. That could be anything you want. There's a lot of really good. I guess I should ask another question. How many people here use Alexa? Okay, figured it'd be more hands. So you probably understand the concept of skills, even if you really haven't explicitly, understood it. When you're asking Alexa for functionality, really you're engaging a skill. There are skills that are provided for you by default, like weather, setting timers and alarms, things like that. But then there are skills like the Jeopardy skill, the Hello Sire, fun games, other things that kind of come with the gadgets and the buttons. Those are all skills that are crafted either by Amazon or third-party developers that you engage with your voice. And again, they're using the Alexa Skills Kit, or ASK for short. There's many different types of Alexa skills. Obviously, the one that we'll be talking about today is smart home skills, but if you've ever asked for a flash briefing or added something to a list or not, or removed something from a list, you're actually using several different types of Alexa skills. We're trying to do our best to keep those maybe not so prevalent. We don't really think of them as applications, and they're not something that you should hunt out. They really are something that you should naturally interact with when you're talking to an Echo or Alexa device. In terms of the kind of back-end architecture, this is a gross simplification, but really what happens is when I talk to a device or even use the cards in the mobile app, for example, really what I'm doing is interacting with an Alexa cloud. And that cloud does a lot of really interesting heavy lifting for the speech that I am uttering into a device. So when that air literally reaches the microphone of the device, gets converted into a digital signal, it gets sent to the cloud and parsed at that point. Now, there's a lot of security concerns about it's always listening. That's semi-true. Really, all it's listening is to a small buffer for the wake word. So if it hears Alexa, that's when she actually starts listening and starts streaming to the cloud. But up to that point, there's a really small buffer where really the only thing she's listening for is Alexa. So at that point, we do speech recognition, natural language understanding, a lot of machine learning, really trying to intelligently figure out what it is you said and really what your intent was. So if I say, I want to play Jeopardy, or I want to know the time, we have to disassemble what that is that you said into something that we can act on, and maybe even potentially act on a skill that you have already enabled. From the Alexa Skills Kit side, there are really two concepts that we have to talk about today. One of them is directives. So you do not really have a direct connection to Alexa. Alexa will send you a directive based on what she heard through the device to your account. So if I speak, Alexa, set a timer. Well, I'll try and think of a third-party one. If I said, Alexa, ask Mike's skill to set a timer, what happens is Mike's skill, this Lambda code that's out in the cloud, will receive a directive from the Alexa cloud. And that directive that comes in says, hey, they said this from this device. It has a lot of packaged information in a JSON file. What Alexa is expecting in return is a response in JSON. So really what we're talking about here is advanced JSON manipulation. That's really probably what this could be called, is really all we're doing is ingesting JSON and sending back JSON. And that's really the guts of it. And we'll see that as we go through. Okay, next thing to talk about, discovery, capabilities. Alexa, when it comes to smart home, is really, really flexible in how you can define what device it is that you're trying to build to be in a smart home. One of the things that we realized early on is we can't just call things smart light, smart switch, because there are so many different things out there that they could be, and so many different capabilities that could be kind of glommed together. You could have a switch that has a thermostat on it. You could have a light that is also a speaker. You could have any different combinations. So what we've done is broken this down into what we refer to as capabilities that allow you to pick and choose what pieces of functionality you need Alexa to be cognizant of with your quote-unquote device. Now, this device is a virtual representation to Alexa. It always is. She doesn't have direct access to your device. The closest that she can come is direct access to your endpoint cloud. And by that, I mean there's auth involved, there's an authentication exchange involved where a token is provided to Alexa from your account that allows you to communicate back to your cloud. Let's say I'm Mike's Lights, and I have an endpoint cloud that keeps track of all my customers' lights and has their state and all of that information. I provide Alexa with a token that says, this person, this user, has the ability to influence this particular device. So as we can see, there's a lot of different options here. There's a ton more. These are just ones I happened to pick out to kind of give you a flavor of what are some of the things that you can do. Okay, so let's talk about endpoint cloud architecture. Typically, you end up with something like this. A lot of our third-party existing integrations have the portion in green where we have an endpoint cloud. So if I have Mike's Lights would be that endpoint cloud. I control what those lights are. I get to do all the cool stuff with IoT device management, like firmware updates and all that stuff that Alexa just does not care about. But what we also do with that is set and check state. Is the light on? What color is the light? What's the temperature set at? All of those elements are controlled by a third-party cloud, right? That's how I control, that's why I offer to my customers. Now, what that third-party cloud looks like, we'll see in a minute, doesn't necessarily have to be external. So from the top, we have endpoints that could be anything. We have the devices that are also maybe on the home network. You can imagine an utterance coming through there, influencing through the Smart Home Skill API to a skill service that allows us to communicate. Again, this is what, that Lambda is really what's doing that JSON manipulation. Ingests the directive and sends back an event. Typically, the minimum that you have to do on the Amazon side is really Lambda. You don't even really have to do login with Amazon. You can use any OAuth provider if you want, but really the Lambda portion is important because that's what Alexa is expecting to communicate. There's a ARN that's given that's associated with the skill ID, and between those two, we can know that this skill is your skill. However, you can also do all of this in AWS. So in addition to logging with Amazon, you can use things like API Gateway, AWS IoT, DynamoDB to store all this. So in fact, your endpoint cloud is really AWS. It's built on services that you've already known and are using potentially through AWS. In this example, it's going to reflect what I'm going to approach in the demo, but really what we've got is a couple of Lambdas handling things like maybe an API service that interfaces with our devices, whatever those happen to be. I'm sorry, I'm a little loose with devices, but in my world, anything from an automobile to a switch to the home itself could be a device. Complicated devices like cooking implements to washers and dryers to anything. Anything that really has some type of state that you can control is really kind of a target for Alexa. Okay, so let's take a look at some sample architectures. First off, in general, we have an Alexa-enabled device, Alexa Smart Home Skill Kit. We can use things like API Gateway, DynamoDB to actually act as pass-through for referential information in the DynamoDB. One of the things I love about AWS IoT is it's very resource-friendly. You can have small implementations on devices using Greengrass or even just a simple script in some cases to communicate state back and forth. But what if you have other information? Like let's say I'm a device manufacturer. Again, maybe it's Mike's Lights. How do I store friendly names, SKUs, firmware numbers, all this other information? You can easily use DynamoDB to reference that information. And when we get into the sample, we'll see an example of that. Lambda is very useful. A lot of serverless computing for Alexa. We try and make it as easy as possible to use Lambda to drive it. You're not necessarily stuck to that. With custom skills, for example, you can use HTTPS, just whatever server you've got. But again, all you're really doing is receiving and sending JSON. AWS IoT, obviously, we can use that as a really clear descriptor of what these devices actually are, what they do, and most importantly, what their state is. OK, let's move on. So in a real world, we might end up with something like this, where we have an API gateway that has maybe 3 endpoints. One that handles directives sent into it. 2, maybe that does endpoint manipulation, create, CRUD, create, read, update, and delete of endpoints. And then 3rd is maybe handling external events. One of the things I haven't talked about is a concept in Alexa called proactive state updates. It's very gnarly sounding. In some respects, it kind of actually is gnarly. But really what it is, it's an out-of-band way for you to signal that something has happened to an endpoint. So in the real world, you could actually walk up to a switch and turn it on or off. You can do a manual operation to send a state change to a device that's in the cloud. And what events and proactive states in particular allows us to do is send that update to Alexa to update her cache, to give her updated real-time information about what the state of that device is. And that's important because what we're all expecting as users of Alexa is speed. We want to have immediacy, right? If you say, Alexa, turn on the light, and you have to stumble around for 5 seconds in the dark, that's not optimum kind of experience. So actually having things like cache state, being able to just check for things as they're happening, as they are needed is important. Again, other examples of kind of real-world stuff we'll see in the sample. So why don't we just actually get into the demonstration, and I'll spend some time talking through that. I think I'll hold off on that, and I'll just go into it first. OK. There we go. Don't know why my screen got all small. So the first thing I want to show you is, and I made that, a CloudFormation template that really reflects what we just saw in that PowerPoint slide. This is already out there, and I'll show you the GitHub link out there so you can grab it. Don't feel like you have to memorize it. There will be a quiz. No, there won't. Won't there? OK. There's a lot of information on here, but there are a couple of things I'd like to point out. We have an API gateway that's handling, again, these 3 directives, endpoints, and events. We've got a couple of Lambdas down there. We've got DynamoDB tables to store some of our referential information, right? We aren't using necessarily one resource. This could actually be simpler if you wanted to. You could source a lot of this out of DynamoDB if speed wasn't a concern. But again, since we're dealing with state, it's best to use something like AWS IoT. Because especially if it's maybe a device that you're creating, you may want to use something like Greengrass to be able to communicate independently on a network up to your own cloud. OK, so what to point out here? What are we trying to accomplish with this? At the highest level, really what this is a virtual device simulator. So I can say things. Oops, I forgot to grab my Echo. Let's see if this works. I'll also give you the tip on the 4 ways that you can talk to Alexa. Well, actually, I guess there's 5 now I think about it. Alexa, turn on sample switch.
The skill linked with sample switch is not enabled. Please enable the skill to control this device.
I know what I did wrong. Alexa, turn on sample black switch.
OK.
Done. Ta-da. So that's a lot for, that's a lot of code to make that happen. Let's walk through what actually just happened. Let's conceptually think about what happened. I sucked in air. I pushed it out from my diaphragm. It went through the air, literally jumped through the air, hit the microphone. Microphone converted that to a digital signal, sent that through my MiFi, through this, up to the cloud, to the Alexa cloud. From there, originally she heard me say sample switch, which was incorrect. I misidentified the device, and being somebody who deals with sample switches and samples all the time, there probably is a skill in my repertoire that's that. That's why she's telling me it's not enabled. But once I correctly identified it, she went in and looked at the devices that she knows about in my account. And in that case, I have one in there called sample black switch. And does a sample black switch actually exist anywhere in the world? Not really. It's just a AWS IoT reference and a DB referential reference. And we should take a look at that right now. So ultimately, before I forget, that request came back from the Alexa cloud to my Lambda. And it said, hey, I heard a turn on request for this device. What are you going to do about it? And I respond, OK. And she says, OK. I do some other stuff in the background to actually store that state, but that's really kind of the sum of it. Okay, so first off, let's take a look at AWS IoT. So I have, that's awful small. Let's move that up. Oops, that's too big. I have a thing type in there with a gruesome GUID name. Again, I am using this as a referential name. This is not something that you would expose to the end user, but as a Mike's Lights, provider, I would associate this with a line item to a customer reference to whatever. This is a device that I know about and I'm going to track. If we look inside of it, there's some information in here. Most importantly is association with my Amazon account. So this is how I know that this is the account that is going to flow through. If we look at the shadow, for example, I have the state of on. So Alexa, turn off sample black switch.
Okay.
So hopefully, if everything's worked okay, ta-da! All right, it already updated on me. That was quick. Right, we've set it to off. So this is a really simple pattern for switches. You can imagine as soon as you start to do things like lighting, where you don't not only have just on or off state, which is one of the capabilities you can add, but you have things like brightness, color, temperature, because you can say things to Alexa like, mute her before I start talking about her. Alexa, set living room lights to white. Alexa, set increase brightness on kitchen lights. Alexa, turn off garage lights. Wherever you happen to have these lights that you can control, you can send different types of golden utterances, if you will, that will control them in different ways. You, as the device manufacturer, get to define what those are and actually specify them in what we call the discovery. So when you, again, if you've all, how many people here actually have smart home integrations with Alexa, actually use it to turn on lights? You've probably gone through the discovery phase where you've said discover or press the discover button or as you enabled the skill. At that point, Alexa goes out to your skill, or excuse me, to the skill that you're using to power those, be that the Samsung or Philips or Lifex or you name it, Lutron, whoever that happens to be, and asks, what devices are we talking about? And guess what comes back? JSON, big JSON file with descriptions of the capabilities and what those devices are, what their names are, so that I can say things like sample black switch and accurately route to the right device. That's all packaged or encoded in that discovery request. Okay, so really quickly, we have a device. In this case, it's called 8D64. We also have a corresponding lookup in the DynamoDB, and if we look at this, it has all the other information, the sample manufacturer, sample black switch. All of this information is actually populated in things like, if we go look at, let's go to my Alexa account and look at my smart home devices, I actually have a sample black switch in there. Let me zoom that in again. Again, it doesn't exist. Not really a device anywhere, but to Alexa and corresponding through my cloud, I can make it exist. And I can send it commands. And if you have code back there to handle it, it can send responses. Now, how you do that in your cloud for your washing machine or automobile or whatever device, garage door, whatever it is, that's on you. I would suggest that you use AWS services because they're awesome, especially AWS IoT. But you can do it. You can build that however you want. In some cases, you're probably coming at it with pre-existing infrastructure anyway. Cancel. I don't know what that was about. I did it again. Okay, so let's take a look at. Okay, we talked about the Lambda. We talked about the DynamoDB. We've got the AWS instance. Before I forget, I'll take a segue here. There are 5 different ways to talk to Alexa. One, obviously through the device. Let me think of, no, I think there's 4. One through the device. Another one is through, this is the skill that actually drives what we've been talking about here. There's a arm that points to an adapter that's handling that JSON for us. I can actually go to the test functionality here and either speak or type text into the simulator. So if you've not ever built a skill, you probably won't ever see this, but it's a handy way if you're developing a quick skill or want to test one out. You can do it through there. Another one is, echosim.io. If you haven't used it, it's actually pretty slick. Again, associated with your account, you can send instructions through the web. And the last one is the mobile app. I don't know if you've known this, but there's a nice little widget or button that you can actually put down that will allow you to give commands through your mobile app. OK, back on track. So now we have, let me get off of this because it's holding my mic. Let's take a look at the Lambda. So what we have is an API. Again, I will point it out. Well, I won't. It's in the CloudFormation structure that there is an API that has 3 endpoints. And one of those is for directives. So when a directive comes in, we can consume it and basically route based on what it is. At a minimum, there are 2 that you have to define. One is auth, for dealing with that authorization token to hold on to the information that Alexa is going to require to reach into your cloud. And the second one is discovery. If you did that, you'd legitimately have a smart home skill that you could build for a connected home device. You wouldn't do anything with it, though. There's no command. You couldn't give it any command to actually process anything. So what we've got in this code here is a handler for an Alexa power controller. That's really small. Let's increase that a bit. Find out where I was. So we have a power controller directive. And again, as its name indicates, it's really a power controller for on or off. So as you saw, I was doing turn on the sample switch, turn off the sample switch, and that's really what this code is doing. Ultimately, all this is doing is packaging up a JSON response and updating it to 2 places in this case. 1, AWS IoT, sending out a shadow update, and 2, sending a response to Alexa that says, there wasn't an error, the command succeeded as normal. And we can see that two portions here. 1, update thing shadow, right? We send a templated version of this that has the actual power state from the utterance that came in, and ultimately the response that we send back to Alexa that says, OK. And you can send errors if there's an error. That's up to you. And you can actually encode context in there as well. One last one I will show you is, let me see here. This sample, which again, I will give you the GitHub repo link at the end here, exists for folks who are trying to build these or trying to understand what's happening. So what we've done is encode them with some deep logging so you can actually see things like, first off, I'll look in the DynamoDB. One of the things that really trips a lot of people up is auth. Dealing with the back and forth flow of OAuth can be a little confusing to people who haven't really maybe enjoyed that frustration. But in this, sample endpoint details, sample smart home, sample users, excuse me. Don't do this in the real world, but it actually we dump out all the information that you see going back and forth in that OAuth flow. The tokens that you're going to need to get authorization, the access tokens that you're going to get when you transfer those to the auth server, they all get logged in here so that you can go in and understand what's there and what's missing. And in some cases, actually pull them out, test them in a different tool that you'll see in a moment, like Postman. OK, so then the other one is CloudWatch. If we look at our logs, one of the easiest ways I've found to go to the right CloudWatch, and I actually just closed it, of course. If I go to the sample endpoint adapter, monitoring, and they just move this again. Everything's moving, always moving. We can see, if we look at this really closely, we've got, let me try and track this down, handle the request, process the request, update the power controller, and then response. So if we break these open a little bit, well, this is maybe not the best example. We can see, it's a little hard to see, but we can actually see the request that came in. So this is Alexa communicating to your service, sending in JSON. Again, and trust me, it's just JSON. But there's information in there on what device it was, what they said, what time it was. All of that information is encoded in there. And if there's also a logged corresponding response, so we can actually see what we sent back to Alexa to say, hey, OK, we set the state to off, and she responds with OK. Or if you have brief mode on, she'll do you, basically. OK, now let's look at the real cool part. The reason this is virtual is so we don't have to monkey around with making a lot of stuff. And what we can do, this is also included inside, I apologize, that's really small. I don't know if I can make Postman any bigger. I wonder if I can zoom. One of these key combos is going to let me zoom. Oh, well. Anyway, so I've got this endpoint API in here to allow me to, again, create and update devices. So let's say I've got one already pre-programmed in here for sample, let's do sample white switch. We'll do something opposite. So if I open that up, really what's going to happen is it's going to take this code and throw it at our API, and that will ultimately create a device and register it so that when we do discovery again, we now have a new device in our repertoire. So if I just send this, hopefully we get an OK back. Yep, we get a response back. Please be 200, please be 200. Yes, it is right there. OK, so now if we go look at our AWS IoT, we have another device. We have another one in here. And again, if we look at our DynamoDB referential information, we have another one. Whoops, I'm in the wrong table. We have another one, but this one is, oops, that's the other one. We now have one that's called white switch. Now, if I, show of hands, if I speak to Alexa, who is muted, and I ask her to turn on the white switch, what will happen? Will she understand me? Show of hands. Yes, she will turn the light on. Sorry, you're wrong. No, you're close. We're all close. We haven't gone through discovery yet, right? She doesn't know about it. So if I say, Alexa, turn on the sample white switch. Alexa, turn on the sample white switch.
Sorry, I didn't find a device named sample white switch.
Right? We haven't gone through discovery. So I can say, Alexa, discover devices. Alexa, discover devices.
Starting discovery. This will take 45 seconds. To connect your lights or plugs, just turn them on now. For locks and other products, refer to the manufacturer's instructions to put them in pairing mode.
Again, also in the logs, I probably won't bore you with looking at it, you'll see the discovery responses come in and logged out, so you can understand when those happen and what you should probably do to handle those. So, I'm sorry, I wasn't listening, Wally. Did she say okay? Maybe. Let's go back and see if she added a white switch. Not yet. Let me try it this way. Many different ways to do the same thing.
Find any new smart home devices. You can try again, or if you need help connecting, tap help in the smart home section of the Alexa app.
Oh, you know what? I know what I did wrong. You're going to see my mistake here. So what I forgot to do was very important. You see this user ID right there? It's set to 0, which is great if you're doing development, because you can just basically say all your development devices are set to a particular user ID. I forgot to set that to mine. So what I can do is actually go into AWS IoT, and we're looking at this value here. You know what? I'm just really gonna do another one really quickly. It's easiest just to start over. I knew I'd forget that. Okay, white switch, user ID's in place. Let's send it. Okay, let's try it again. Alexa, discover devices.
Starting discovery. This will take 45 seconds. To connect your lights or plugs, just turn them on now. For locks and other products, refer to the manufacturer's instructions to put them in pairing mode.
So now we have 3. 2 of them are associated to my account. So you can imagine, as a device cloud manufacturer, I could have entire categories of these that are user bases for a particular region or a particular locale or a particular group of users that really reference what these devices are. And on the cloud device side, they're going to go off and actually, again, maybe use Greengrass, maybe use something to update those in the background. Okay, let's go back to here.
I found one new switch called sample white switch.
Yay.
To control it, say, turn off sample white switch.
It's already off. That's kind of not a good command. How about turn on, Alexa, turn on sample white switch.
Okay.
Ta-da! That's a lot of code to make that happen again. OK, let's go to the key points slide. I think I have to do, oh, this one. OK, key points. API gateway in this case is really just used for message routing. And again, all we're doing is JSON, pushing JSON around. That's really kind of the sum total of it. Lambda is the logical router, handling the compute. Whatever you need to do. I needed to make a decision on whether or not what I was dealing with was a discovery directive or an auth directive, a power directive, a temperature directive. All of those get handled, in this case serverless, through Lambda. Now, I didn't show it to you, but in my example, there are 2 Lambdas, because one of them is the API. The actual skill Lambda doesn't look like any normal skill Lambda that you might see in our other code, because really all it is a pass-through straight to the API. It receives a directive and sends that straight to the API for its response. AWS IoT, state arbiter, right? It handles that state from Alexa that allows us to turn it on. In this case, I happen to be using Bodo 3 and Python in the background to send a, thank you. I just need a Alexa shut up command. And then from the device cloud, device state changes, like those proactive states that we talked about. Again, if I walk up to a device and change its state independently of what I've told to do through Alexa. And then finally, DynamoDB, just basically handling all the information or large chunks or binary blobs or all that other stuff that we don't want to handle in a constrained device that may be sitting at the edge of a network somewhere. And summary, this is a great way to solve some interesting challenges. Combining kind of that voice control on top of AWS IoT probably isn't what first jumped into a lot of people's minds with the connected home, but really a connected home is just a home filled with IoT devices. If you look at a device as a thing, again, a washer, a dryer, a car, a light bulb, a switch, a fan, a radio, a sound bar, they're all just things. They all have connectivity nowadays, and they all exist on a network. We took a look at the common services, and we gave some examples of what was going on. OK, anything else, Wally, before we go on to the submit feedback and all of that? Yep. You got anything?
And everyone's still hearing me. I moved my mic around. So no, I think that's basically it. Thank you so much for joining. There is feedback, so we want to make sessions better for you. We want to understand what you're interested in learning and hearing about. So feedback is always welcome. If you like it, I'll do what my Lyft driver said to me. Give me 5 stars. Give us a great rating. But if there's things we can work on, we do want to hear about it.
Yeah, if you have any questions, I'll be hanging around for a while. I won't walk away until everybody gets their questions asked. So, oh, yeah, thank you. A couple other things. One, I want very important links on here. GitHub.com/Alexa. There's an Alexa smart home section. You'll find all this code that I just showed you in the sample backend, plus instructions on how to implement it. So if you want to go home tonight or go back to the hotel or whatever and fire up your own CloudFormation template and recreate your own virtual devices, have at it.
And that's basically it. I see a few questions, so maybe we can take them up here if possible. I know we ran right at time, but we'll be right off stage to answer any questions. So thank you so much.
Thank you.